Okay, welcome back. Week two of quarter three, and we're going to be talking about factoring trinomials, which is something that we've all done before. We did it in intermediate algebra. And in this case, we're going to be talking about factoring trinomials when a is equal to 1. And you might be thinking, well, what do you mean a is equal to 1? Well, a trinomial is any expression that has three terms in it. And in this case, we are talking about trinomials that are going to look exactly like this trinomial right here, ax squared plus bx plus c. And the letters a, b, and c represent numbers of some sort. And when I say numbers, I mean integers. So you can have any sort of integer where a, b, and c are. Now, when we say a is equal to 1, what we mean is that the number in front of x squared is going to be 1. So what's going to happen is that 1 is actually not going to show up because we don't need to write the 1 next to the x squared because it's implied when something is by itself that there is a 1 in front of it. So when we factor a trinomial with a is equal to 1, we change it into two binomials that are multiplied together. So you can see down in the bottom, we have ax squared plus bx plus c, and then it's equal to two binomials. And we have the letter h and the letter k in there. And I chose the letter h and k just because they're two numbers that are two letters that represent integers again. And what we want when we factor a trinomial into two binomials is we want h and k, when we multiply them together, we want them to be equal to c, and you can see that right here. But when we add them together, we want them to be equal to b. All right, and there's a method that we've used in the past that you've probably seen in the past where your teacher makes a big X on the board and they put the number 20 on top and they put the number 9 on the bottom and they say, all right, we're going to multiply to equal 20. We're going to add to equal 9. And basically, we just have to find two numbers that do that multiply to 20, that add to 9. The easiest way to do that is to just look at the number 20 and say we have the factors of 20 are 1 times 20, 2 times 10, 3 doesn't work, but 4 does, 4 times 5. And since we have 4 and 5, they're right next to each other. If you remember from the last lesson, if we go one more step and do 5 times 4, we're going to repeat, so we don't want to repeat. So as soon as we start to repeat, we can stop. And then all we have to do is look at these pairs of numbers and say which pair adds up to 9. Well, this one's pretty obvious. It's the last one. So 4 and 5. So what we can do is we can say, all right, generally speaking, your teacher would have done, all right, 4 and 5. And then we could write the two binomials. So we would write the two binomials like this. And since a is equal to 1, the first term is always going to be the same. And it's always going to multiply to equal whatever the first term in the trinomial is. So if it's x squared, the first term will be x in each binomial because x times x is x squared. If it were something else like x to the fourth, then these would be x squared and x squared. Or if it's x to the sixth, it would be x to the third and x to the third. And you might notice a little pattern there. It's always an even number. So it's in the original trinomial, it's always going to be an even number. You can't ever have an odd number. All right, so you couldn't have x to the third to start off a trinomial and expect to be able to factor it this way because you can't find something that you can multiply by itself to equal x to the third. All right, and so we have x's first, and then since we have 4 and 5, and in this case they're both positive, we can just write plus 4 and plus 5. Okay, so it's as simple as that. Now I could have put the 5 where the 4 is and the 4 where the 5 is. It doesn't matter. The order doesn't matter on these when we have a equal to 1. All right, so let's go through a few more examples. And what I would hope is that you eventually just get to the point where you can start to look at this 12. You don't need to make the big X, right? So you look at the 12 and you say, 12 is 1 times 12, 2 times 6, 3 times 4. And this one, again, is fairly obvious. We wanted to add to equal 7, so that's the 3 and the 4, right? And since we're starting with x squared, our binomials are just going to be x plus 3 x plus 4. Okay, hopefully you can get to the point where you don't necessarily need to do a whole lot of work to be able to figure this out, because you can just look at the number and say, what multiplies to equal that last number that I know is going to add to equal the middle number or the b term, right? And when we have addition, it's relatively straightforward and simple because everything's positive, right? We can mix it up a little bit where if we have the middle term is negative, if the middle term is negative and the c term is positive, so in this case, negative 12, positive 35, we know that both of our numbers in our binomials have to be negative, because the only way we can make a positive number by multiplying and a negative number by adding is if both numbers are negative. Okay, so, and when I do this, I'm not going to list a whole bunch of negative numbers. I'm still just going to list, hey, 1 and 35 and 5 and 7. And then I'm just going to look at those and say, all right, I have a 12. And hopefully you can see that the 5 and the 7 add up to 12, but I want them to be negative, so that means they just both have to be negative. All right, so I have x minus 5, x minus 7. Okay, you could make a list with all the negatives in there too if you wanted to. You could say negative 1 times negative 35, negative 5 times negative 7, but that ends up being a lot of extra writing. And if you can just remember that if it's positive, I know I can have both positive numbers or both negative numbers. It's going to be a little easier that way. All right, so that's one way that factoring trinomials can get a little bit goofy when we have two negative numbers involved. And then this way, when we have the middle term or the b term is positive and the c term is negative, and this also applies if both of them are negative, that means that the only way we can have a negative 12 is if we multiply a positive number by a negative number. So this is where we could make a huge list. So we could start off by doing stuff like this. Okay, but we know, hey, that has to be a negative, so we could make each one of these negative here. But then we could rewrite the list, and I'm going to write it backwards instead of front way, and you'll see why here in a second. But then I could make all these negative. Okay, so now we have all of the possible combinations that multiply to equal negative 12. You don't have to do this. When I do it, I just do the positive, and then I look at it and I say, when I have a 4 here, I'm basically looking for numbers that have a difference of 4. Okay, and in this case, what works is the negative 2 and the 6. Because if we flip this around and say 6 minus 2, well, that's equal to 4. Okay, and that's what we want. So we're going to write this as x minus 2 and x plus 6. Okay, and I simply wrote it that way because that's the order that I have the two numbers in that I highlighted green there. If you want to write the 6 first and the negative 2 in the second one, that's perfectly fine. Okay, so these are basically the three different types of things that you're going to run into when you're factoring trinomials like this. All right. There are some special circumstances, and so example D is a good example of a special circumstance that you're going to run into. The difference between D and the three that we just did is we have a y squared and a y right there. All right, and the only thing that this does is it causes us to have a y with the second term in each one of the binomials. All right, so instead of having just an x in the front to start with, we could also just throw a y in the back in the second term. Okay, and then we could kind of just ignore the y there and say, hey, it's actually just x squared plus 7x plus 6 that I need to now think about factoring so I can find the two numbers that I'm going to put next to the y. And hopefully this one's fairly obvious because there's only two factor pairs for 6. It's 1 and 6 and 2 and 3. And the one that adds up to 7 is 1 and 6. So I'm going to say plus 1y plus 6y. All right, and the reason we have that y there is because we have a y squared in the last term, and we always want this last term to multiply to equal the last term in our trinomial. So 1y times 6y squared, or sorry, 1y times 6y is 6y squared. Okay, and then having that y with the 1 and the 6 is going to give us the y we need for the middle term as well. Okay, one way you can kind of just double check this, whoops, I don't want to do that, is if you just do the box method really quickly, and you do x and 1y, x and 6y, and you can kind of see what's going to happen. So we have x squared, we have 1xy. Okay, I put the x in between the 1 and the y because I like to put things in alphabetical order. And I'm going to do the same thing here, 6xy. And then we have the 6y squared. So you can see we get the x squared that we want. We get the 6y squared that we want. But then when we add these two together, we end up with the 7xy, which is the middle term, which is what we want. Okay, so if you ever doubt yourself or your answer, just turn it around, multiply those binomials together, and you should be able to see whether or not you have the right answer or not. Okay, so that's one kind of special circumstance that you're going to run into. Another special circumstance, and I kind of mentioned this earlier in the video, the idea of having even numbered exponents on the x term in the beginning. You can factor anything that has an even numbered exponent for the first term. If it has an odd exponent, it's not going to work. The thing to remember is, just like with x squared, we would put an x and an x in the beginning of the binomials. But in this case, we have an x to the fourth. Well, the thing that's multiplied by itself to equal x to the fourth is x squared. So we're just going to write an x squared here. And one thing that kind of tip you off is there's an x squared in the middle term. So that means that we have to have x squared in the beginning of each binomial in order to get that x squared in the middle term. Okay, and then we just look at the 6. We've already done 6 a few times, so it's 1 times 6 and 2 times 3. And the only two that add up to 5 are 2 and 3. So we're going to have plus 2 and plus 3. Okay, so the only difference with this is when we have that even exponent that's greater than 2, we just split it in half. So x squared and x squared is half of 4, right? All right, so that's another scenario that you're going to run into. And then one other thing that you can run into, and I've mentioned this in the past about math and how one of the goals of math, or one of the things that we always want to think about, is simplifying things. Simplify things, and it's going to make your life a lot easier, because you might look at this and say, hey, wait a minute, that 3 is in front of the x squared. That means a is equal to 3, not 1. And you're right. However, what you should notice is that each one of these terms has a number that's divisible by 3. So what we can do is we can factor a 3 out, kind of like we did on GCF. We can factor a 3 out and put it on the outside. And when we do, we end up with x squared minus 8x minus 20. And now this is a trinomial that has a equal to 1 that we can go ahead and factor. And so when we write our answer, what we're going to do is we're just going to have that 3 on the outside, and we're going to change that trinomial into two binomials. Since it's x squared, we're going to have an x and an x in the beginning. And now we should look at that 20 and be able to try and figure out what numbers are going to go in our binomials. So we have 1 and 20, 2 and 10, 4 and 5. And in this case, they're both negative. So this is kind of like the third example C, I think it was. When they're both negative, the only way to multiply to a negative number and then add to a negative number is if one number is negative and one number is positive. Okay, so that means we're going to look for the difference between these terms down here. If you look at 2 and 10, the difference between 2 and 10 is 8, and that's what we want. And since the 8 is negative, that means the bigger number is going to be negative here, so it's going to be a negative 10 and a positive 2. And now it doesn't matter which binomial you put those two numbers in, it's going to work the same either way. So I could have put the 2 first and the -10 second. I think that's it. Oh no, there's one more. Oh, it's similar. Oh, it's similar, but it adds one little extra thing. We've got, again, this idea of simplifying. And in this case, that idea of GCF, we're going to factor this by GCF first, and then we're going to factor the trinomial that's left, hopefully. So in this case, we can look at this and say I've got a 2, 26, and 84. They're all even. That means I can factor out a 2. And then when we're factoring by GCF, remember we look for the smallest exponent. So I'm going to pull an x squared out of each one of those. And so when I do, I'm left with an x squared in the first term. I'm left with a 13x in the middle term. And then I'm left with 42 in the last term. And one thing to kind of think about is when we're trying to factor trinomials, we always want them to look like ax squared plus bx plus c. And this one does, because we have an x squared term. We have an x term in the middle, and then we have just a constant, or the c term, at the end. Okay, so now we can go ahead and factor this trinomial. And if we look at the number 42, 42 can be written as 1 times 42, 2 times 21, 3 times 14, 4 doesn't work, 5 doesn't work, 6 works, so we have 6 times 7. And then 6 and 7, again, we're at that point where the next one would be 7 times 6, and I don't need to write it because then I'd be repeating myself, right? And in this case, since it's positive 42 and a negative 13, that means both the numbers have to be negative, and the two that work are 6 and 7. So we're going to write this as 2x squared times x minus 6, x minus 7. And there we go. All right, now I think that is it. That is it. All right, so there's an assignment out there for you to work on with factoring trinomials when a is equal to 1. And if you have any questions, please let me know.